All right, good people. So let us kind of compare both theorems and make sure that we understand what is necessary in each. So when we're talking about the intermediate value theorem, what we need to make sure is that we have continuity. Continuity on the closed interval is going to help us use the intermediate value theorem. When I'm using the mean value theorem, I need continuity, but I also need differentiability. So I got to have both. And I got to have them on the same interval, but one of them is closed and one of them is open. Just think continuity is closed. So CC, continuity closed, differentiable is open. So what are we looking for? We're looking for a conclusion. I'm sorry, with the intermediate value theorem, we're looking for a conclusion about the values of the function given. In other words, if they give me a table, if they give me a graph, if they give me an equation, it's all about, they're asking me something about those function values. Whereas if I'm doing the mean value theorem, the conclusion that they're looking for is about the rate of change, some would say the derivative, of the function given. And we're going to see that certainly as we look at these two examples. And maybe I shouldn't say function values give, I should just say function given. Because when I look at these two examples, I'm just given a table, right? And actually, it's the same table, but the problem is different. So the first question on the left side says, is there a time C for C's that are between 0 and 9 such that V of C is equal to -1? This is the table, the function table for V. So that's how I know I need to do the intermediate value theorem. Whereas if I do the other example, read the other example, it's talking about, is there a time C for C's between 0 and 9 such that A of C is equal to -1? Well, A of C is the derivative of the velocity, not the same thing. So therefore, that's how I know that it's the mean value theorem. If they're asking me things about the derivative of whatever they give me, whether they give it to me in a table, whether they give it to me in a graph, whether they give it to me in an equation, then they're really looking for me to use the mean value theorem. But look at the phrasing. Is there a time? Is there a point? Is there an x value? Is there a c value? They're asking about the existence of something. You know that we're going to have to use either the intermediate value theorem or the mean value theorem. So in terms of the work that we need to show, well, for the intermediate value theorem, what they tell us in the problem here is that the velocity is differentiable. So you can say, since the velocity, or since v of t, why don't we just say that? Since v of t is differentiable, then v of t is continuous. You have to be explicit about what you know about the relationship between differentiability and continuity. Like you can say, oh, well, they should know. If they told me that's differentiable, then obviously it's continuous. Well, they know that, but they want to make sure you know that. And so you have to explicitly write it out. Since the velocity is differentiable, then the velocity is continuous. That's what I need to show. The other thing you need to show is what is v of 0? What is v of 9? What are these two values? Well, v of 0 is 5, and v of 9 is -4. Is the value that they're concerned about or that they want, is it between those? Because if it is, then you need to say, again, you need to say it outright. And v of c is between v of 0 and v of 9. You could also write it like this, is in between. I am going to have to write this way because V of 9 is a smaller value than V of 0, but V of C is between. So I can say this, or I can say this. But they mean the same. They're the same work that I have to show. I have to show that the condition is met. How? With the intermediate value theorem, it has to be about continuity, and it has to be about whatever y value output function value they're looking for. It has to be between the endpoint y values, and I just showed that it is, because v of 0 is 5, v of 9 is negative 4, so therefore v of c, which is negative 1, is between the other two. Once you declare that, then you can say, well, since v of t is continuous on the interval from 0 to 9, then the intermediate, I'm going to write it out, the intermediate value theorem is going to guarantee me something. What is it going to guarantee me? That there is a time c. You can even say there's a t equals c, because I guess it would be the same thing. As for that c value between 0 and 9, such that v of c is equal to negative 1. Right? I have to say the statement that the function is continuous. I already showed that it's continuous. I already showed that v of c is between the endpoints. So then the intermediate value theorem guarantees that there's a time in that window such that v of c is equal to negative 1. And that's it. But you have to be explicit with your thinking, with the, I guess, conditions that you find, because you can't assume that, oh yeah, they know it. Well, yeah, they know how to do the problem. They want to see that you know how to do the problem and you know what to look for. So when I'm doing the mean value theorem, I need two things, right? So again, they tell me, according to what's written here, the bug's velocity is differentiable. Okay, so if it's differentiable, that means v of t is differentiable on the open interval. And v of t is continuous. How do I know it's continuous? Oh, because it's differentiable on the closed interval. And then I need to show what the average rate of change is. Let's see, v of 9. V of 9 would be negative 4 minus v of 0 is 5 over 9. So then this is just going to be negative 1. So the average rate of change is negative 1. And then I'm supposed to show that there's a point where the derivative, the IROC, the instantaneous rate of change, equals that number. So we just showed that, because if it's differentiable and it is continuous, then whatever the slope of the endpoints is, there has to be a point where the derivative is equal to that. So then I can say a of c, which is the derivative of velocity, has to equal that. According to the mean value theorem, there has to be a point where the derivative is equal to the slope of the tangent line, the slope of the secant line, which we happen to find that it's negative 1. So therefore, since v of t is differentiable on the open interval, and v of t, I'm sorry, I'm not going to repeat it, and v of t is continuous on the closed interval, the mean value theorem guarantees that a of c, which is equal to v prime of c, is equal to v of 9 minus v of 0 over 9 minus 0, which equals negative 1. This is what the mean value theorem says in its statement. But we know that v prime is really acceleration, and we know that this slope actually produces negative 1. And so that's exactly what we're looking for. We're looking to show that there's a point where the acceleration, the derivative of v, is equal to negative 1, which is the average rate of change of v over that time interval. This is the difference between the two. And it's important that you remember, especially in this second row of boxes, what you're going to be looking for. How do I know whether it's one or the other? Well, are they talking about making a conclusion about the function that you're given, or are they asking you to make a conclusion about the rate of change of the function that you're given? Because that's going to determine which one you're going to use.